The Doppler effect is the change in frequency of a wave dependent on whether the source is moving towards or away from the receiver. It's hard to comprehend by just hearing it, so I found a really helpful demonstration on how it works. In the demonstration, you can see the source is emitting a wave at a frequency of 100 Hz. When the source is stationary, the stationary receiver observes the 100 Hz. But when the source is moving towards the receiver at, let's say, 0.5 units of speed, the observed hertz are 200, and the waves moving towards the receiver are more compact and closer together, while the waves moving away from the receiver are more spread out.
The Doppler effect is caused when the source of a waveform, such as light or sound, sends out waves at a regular rate or frequency, but there is a constant relative motion between the source and observer, causing the observed frequency to change. If that source is moving with respect to the stationary observer, the speed of the waveform remains constant, but the distance between the emitted waves decreases in the direction that the source is moving and increases in the opposite direction. Longer wavelengths of light have lower frequency and shorter wavelengths have higher frequency. From the Doppler effect, we know that when the sources move towards the observer, any waves that emit that you measure are shifted to shorter wavelengths, which is called blue shift. And when the source moves away from the observer, any waves they emit that you measure are shifted to longer wavelengths, which is called red shift.
Most waves affected by the Doppler effect work similarly, and sound is no exception. Change is still caused by the motion of the source, but in a different way. The variable frequency is synonymous with pitch, meaning that frequency directly correlates to the pitch. So when the source moves toward the receiver, the wavelength in front of the source decreases, causing the frequency to increase. We know this because of the formula V equals lambda f. So when the source is moving towards the stationary receiver, the pitch increases, causing the sound to increase. But when the source moves past the receiver, the wavelength is longer and causes the frequency to be smaller, and thus the pitch to also be smaller. This, in turn, makes the sound observed drop frantically. Here's an example of how the Doppler effect works with sound. As you can see, the car, aka the source, is moving towards the stationary receiver, my phone, at a relatively slow velocity. The sound picked up from my phone when the car was moving towards it was consistently loud, only swaying from time to time due to a change in velocity. But when the car passed me, the sound dropped heavily.
In a nutshell, the Doppler effect is a fluctuation in frequency depending on whether the source of the moving object that you are measuring is going towards the observer or away from the observer. If the source is 10 meters away and moving towards you, it will sound louder than if it was 10 meters away and moving away from you, because the waves that the source emits are moving in your direction. Also, any waves that are released by the source that is moving towards you are called blue shifted, and any waves released by the source that's moving away from you is called red shifted. The craziest thing is that the Doppler effect applies for both light and sound, which seem like two completely different things, considering how differently light and sound act.